was built to last. With the webs I'm weaving, I could change the past. With all I'm achieving, got my foot on the gas. Never stop competing. If you break like glass, then this life's gonna end.
I want to be the best in the game.
Hello guys. So today we're gonna be looking at a problem on pressure. So the question says a reservoir 500 meter deep is filled with a fluid of density 850 kilogram per meter cube. If the atmospheric pressure is 1.05 times 10 raised to the power 5 Newton per meter square, the pressure at the bottom of the reservoir is... Now, so we're looking for the pressure, and don't forget the parameters that we have in the problem. So we're going to take the parameters one after the other, and don't forget your G, that is your gravity, is 10 meters per second square. All right, so let's start. So solutions now. So let's start with this. Now, we're told in the question that a reservoir 500 meter deep. Of course, that is the height of the reservoir. So that is how deep. So that is height. So we have H, which is equal to 500 meter. It's filled with a fluid of density. All right. So we have density, that is rho. So density is 850 kilogram per meter cube. All right. Now, it says if the atmospheric pressure, that is atmospheric pressure, is 1.05 times 10 raised to the power 5 Newton per meter square, then we have to find the pressure at the bottom of the reservoir. So we're looking for pressure now. So pressure is this. So we're looking for pressure. And don't forget, we're given G, that is the gravity, which is 10 meter per second square. All right. Now, so there's a general formula that combines all these parameters together. So we're looking for the pressure. So the pressure is equal to the atmospheric pressure plus rho Hg. Take note of this formula. The pressure is equal to atmospheric pressure plus rho Hg. So that is the density, the height, and the gravity. So take note of this formula. This is a very, very important formula. You need to take note of that. So now let's go on. So we can see now that we have the atmospheric pressure to be 1.05 multiplied by 10 raised to the power 5 plus, now don't forget, we have rho, which is density, which is 850. That is 850 multiplied by the height, which is 500 multiplied by gravity, which is 10. And of course, so we still have 1.05 multiplied by 10 raised to the power 5 plus, now if you multiply all this together, you'll be having 4250000. All right. So we have 4250000. Now, this is where the work becomes a little bit interesting, because now there is no way you're going to have, because this is in a standard form and this is just in a different form. So they are in different forms. So there's a way you can go about it, and that is why your mathematics is very, very key. If you are very good with your mathematics, I think this should be very easy for you. So I'm going to show you what to do here. So so we have 1.05 multiplied by 10 raised to the power 5 plus, now we have 4250000. Now, if I can turn this one to standard form 2, I can say that is 1, 2, 3, 4, 5, 6. Now, so let's see what we're going to do here. So that will be, so I can say this one is something as 4.25 multiplied by 10 raised to the power 6. Yes, in standard form, that'll be 4.25 times 10 raised to the power 6. Oh, wow. I think we're having different, powers now. So we're having 10 raised to the power 5 here, we're having 10 raised to the power 6 here. So how do I go about this? Because this has to do with addition. So, and there's no way you can add these guys together. So the best thing you can do is you can transform this guy. All right. So from what we got here, we realize that we have 10 raised to the power 6, and we have 4.355. And of course, if you do that together, this is like multiplication, right? So we can say that that will be 4.355 times 10 raised to the power of 6. So therefore, I can say my pressure at the bottom of the reservoir is equal to 4.355 times 10 raised to the power 6. And don't forget the unit. The unit for pressure is Newton per meter square. So that gives us our final answer to be 4.355 times 10 raised to the power 6 Newton per meter square. All right, guys. So now we're going to move on to the next question, because we're going to be having one other question so that you can understand how you're going to solve a different question as regards this. All right, guys. All right, guys. So from the last question we did earlier, so we want to solve this problem and see how easy we can easily dissect this problem. All right, so let's go. The question says the atmospheric pressure due to water is 1.3 times 10 raised to the power 6 Newton per meter square. Of course, we know that will be your atmospheric pressure, and that is 1.3 times 10 raised to the power 6 Newton per meter square. All right. So the question says, what is the total pressure at the bottom of an ocean 10-meter deep? So we are looking for the pressure. So don't forget that. Looking for the pressure. And we're given that the height, or how deep the ocean is 10 meters. So that is the depth. So the depth of the ocean is 10 meters. And don't forget that we have the density of water, which is a constant. The density of water is 1,000 kilogram per meter cube. So we have density of water to be 1,000 kilogram per meter cube. And we also have our G, which is a constant also. That'll be 10 meter per second square. Now, with all these parameters that we have here, we can easily see that this is also very easy. So let's go back to our formula that I gave you guys earlier. So we had that our pressure, that is total pressure. Now because it's find that what is the total pressure, that is the full pressure. So what is total pressure? So total pressure now will be atmospheric pressure plus rho hg. Please don't forget this guy. This is always very, very important. Don't forget this. Now, so we have atmospheric to be 1.3 times 10 raised to the power 6 plus your rho density, which is 1,000, multiplied by your h, which is the height, which is 10, multiplied by your g, which is also 10. Now, this is very easy. Okay, so we can say that is 1.3 times 10 raised to the power 6 plus, now if you multiply all this together, this is like 100,000. So that is 100,000. So we have 100,000, and of course I can say that is 1.3 times 10 raised to the power of 6 plus, now if you write this in standard form, I can say this is something as 1 times 10 raised to the power of 5. 1 times 10 raised to the power of 5. Yeah, because we have 1, 2, 3, 4, 5. So we have 5 zeros there. So that will be 1 times 10 to the power 5. Or you can write it as 10 to the power 5. I mean, still the same thing. So now, but we had a similar problem, from what we did earlier, from the last problem we did. We had a similar problem when you have different powers. So you have 10 to the power 6 here, and you have 10 to the power 5 here. So the best thing you can do is to make sure that you transform the other one to be 10 raised to the power 6. So what do I mean? I have 1.3 times 10 raised to the power 6 plus, now you know that I can say this is something as 0.1 times 10 raised to the power 6. Yeah, it's still the same thing. Is 0.1 times 10 raised to the power 6 is same thing as 10 raised to the power 5. Yeah, it's still the same thing because this is minus 1. So minus 1 plus 6. Minus 1 plus 6 is 5. So you back to this. So it's still the same. So this guy and this guy, they're still the same thing. That's why I said your mathematics must be very, very strong before you can actually convert this guy to be the same thing. All right, so let's move on now. We can see now that we have 10 raised to the power 6 from the two sides now. So I can collect, what is common to the both of them. So I can say that is 10 raised to the power of 6 into the brackets of what is left here is 1.3. So we have 1.3 plus what is left here is 0.1. 0.1. Of course, 1.3 plus 0.1 is 1.4. So I can say this is 10 raised to the power of 6 bracket 1.4. So meaning I'm having 1.4 times 10 raised to the power of 6. So my total pressure is 1.4 times 10 raised to the power 6 Newton per meter square. So this is the total pressure at the bottom of the ocean. So I think with this two problem that we just did now, we can easily see that what you just need is just get the right formula and the parameters right, and you can easily see that is very easy. Okay, so thank you guys, and I think we're gonna watch out for more videos. All right, thank you.